Hey there. Today we're going to learn about the difference between atoms, molecules, and compounds. It's going to be an entry in your notebook, so make sure you have your notebooks out. You also should have some scissors and glue and a sheet that looks like this. All that stuff is in the front of the room. In your notebooks, we're going to start a new page titled Molecules and Compounds, and this is going to be page 17. You're going to add it to your table of contents too, which is at the front of the board. So just make sure your table of contents reflects that. I'm going to be collecting notebooks again this quarter around the 5-week mark, so make sure you're keeping up to date with all this. So table of contents and a new page titled 17. So you're going to cut out this box and paste it in your notebooks, okay? It's going to look like this after you cut it out. You'll cut down the sides to make 4 tabs. And then where it says glue, you're going to actually glue it into your notebook. So it'll be face down like that. You're going to fold the tabs over, all 4 tabs. Yours is going to be a little different than mine, a little better than mine. All 4 tabs are going to be like that. The glue side's going to be down in your notebook, and then you'll be able to open the tabs like so. Okay? Glue sticks and sheets and scissors are in the front of the room. I don't have a whole lot of glue sticks left. We've been using them a lot. So if you don't get a glue stick right away, that's fine. Just focus on getting this cut out, getting it folded, and then we'll take the notes and you can glue it later. So grab all that stuff now and get started. So there's 4 tabs. One tab is going to be element, one is going to be molecule, mixture, and compound. Like I said, this is going to look a little different for you. Yours is going to be separated a little bit. Element, molecule, compound, and mixture. It really doesn't matter which tab you put each on as long as all 4 of them are on there and you put the definitions under the right one. Okay? So, we've been talking about atoms. Atoms are the smallest known particle. I mean, they're made up of all these subatomic particles that we know of too, but atom is the smallest particle. It is so tiny that there are more atoms in 1 grain of sand than there are grains of sand on the entire planet. So just think about that. It's really putting it into perspective about how tiny these atoms actually are. Another fun fact I wanted to share with you is that atoms are mostly empty space. There's the nucleus and the electrons that float around it. So all that empty space is actually a large amount of the atom size. And if you took out that empty space, which we are all made of atoms, everything is made of atoms. If you took that empty space, the whole world's human population would fit into the size of a sugar cube, a tiny little sugar cube, because we are mostly empty space. We're mostly that space between the nucleus and the electrons, which is pretty incredible to think about. Fun fact. Okay, so just as a review, atoms are made of protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Most of you did really well on that quiz, remembering that. And electrons orbit around the nucleus. Each element on the periodic table has different sized atoms. So that the different sizes are actually the number of protons in that nucleus, which makes up the larger and larger elements. So under element, I want you to write down that it's made up of 1 type of atom. So we know that each element has a certain amount of protons in its nucleus. So 1 type of atom, like carbon, has a certain number of protons in its nucleus. So underneath your tab, open it up. You can write it here or you can write it, I would write it here. Maybe you can write the definition and the example over here or vice versa. So element made up of only 1 type of atom, and an example is carbon. And put the atomic symbol there too, C. So that is an element. Mixture. Under mixture, we have 2 different atoms that are not chemically joined. We've talked about this already, but I wanted to put this in your notes again because I want you to be able to compare mixtures and compounds. So putting it in here, mixture is 2 different types of atoms that are not chemically joined. We talked about how we can separate mixtures out using a bunch of different means. So sand and water is one of those examples. So under mixture, just make sure you're writing 2 or more different types of atoms that are not chemically joined and put your example sand and water. Next, we have a molecule. Now, a molecule is 2 or more atoms that are chemically joined. So oxygen, although oxygen is an element, the oxygen that we breathe in is actually 2 oxygen atoms. So O2 is our oxygen that we breathe. So under molecule, 2 or more atoms that are chemically joined, and an example is our oxygen. Then we have compounds. Now compounds make up most of everything that we know, okay? Like water, for example, that was my example that I put down. Now this is 2 or more different atoms that are chemically joined. So that's the difference between a compound and a molecule. A molecule is any atoms that are joined together. So compounds are actually molecules, but a compound has to be 2 different atoms. So one example that I put down is H2O. We'll talk about H2O a lot. It's just the easiest thing to reference. So you can see that there is the element hydrogen. There are 2 hydrogens and 1 oxygen in water. So here's an example of the differences between compounds and molecules. You can see that hydrogen, 2 hydrogen elements or atoms together make the hydrogen compound, and you can see that across the board. There are some elements that are normally found combined in a molecule form in nature. We'll talk about why that is in a second. And then nitrogen oxide here, this is nitrogen and oxygen together are water, 2 hydrogens and an oxygen. These are all compounds. So why do they combine? We talked about our valence electrons and how those valence electrons are charged, and they are, if the valence shell, that last shell of an atom is not full, that atom is constantly looking to fill that shell with another electron. So the electrons are moving back and forth, and this is why they combine. I'm going to show you a short, another short video on BrainPop about chemical bonds and why they combine. All right, let's get this going. I don't know if it works like that, so let's just do it like this. YouTube.
All done? Dear Tim and Moby, how do hydrogen and oxygen stick together to make water? Atomic glue or something? From Tabitha. Actually, she's not that far off. Atoms do tend to stick together, almost as if they were glued. If they didn't, there wouldn't be any visible stuff. Just a bunch of microscopic atoms floating around by themselves. Whoa. But atoms like to stick together, and the reason has to do with what's inside them. Atoms are made up of 3 basic particles: positively charged protons, negatively charged electrons, and neutrons, which have no charge. Protons and neutrons clump together in the center of an atom, forming its nucleus. Electrons whiz around the nucleus at different distances, which we call shells. Oh, shells aren't really perfect circles. This is just a simple model. In reality, electrons orbit the nucleus in 3-dimensional patterns called clouds. But the circular model helps us see that each shell can hold a certain number of electrons. The first shell, closest to the nucleus, can hold 2. The second shell can hold 8 electrons, while the third shell can hold up to 18, and so on. And this is where things get sticky. Sticky. The number of electrons in an atom's outermost shell control how reactive, or likely to bond, it is. When the outer shell is completely full, the atom is inert, meaning it will resist bonding.
Get lost.
8 electrons is another stable pattern, even in shells that can hold way more. In all of the noble gases, the outer shell is either full or has 8 electrons. That's why they almost never form bonds. The other elements on the table tend to occur in molecules, sets of 2 or more atoms bonded together. It helps to think of atoms as wanting to be inert, so they try to gain or lose electrons to reach a stable number. Well, take water. It's made of 2 hydrogen atoms and 1 oxygen atom. As you can see, hydrogen has 1 electron in its outermost shell. It would love to have 1 more, since 2 electrons would fill that shell up. Oxygen has 6 electrons in its outer shell. Since the second shell can hold 8 electrons, oxygen is looking for 2 more. So, oxygen shares a pair of electrons with 1 hydrogen and another pair of electrons with another hydrogen. Now all 3 atoms are stable.
Yay! Yay!
This sharing of electron pairs is called a covalent bond. Nope, that's not the only way atoms stick together. Ionic bonds happen when one atom takes an electron from another.
Yoinkers!
The extra electron gives the first atom a negative charge, and the other atom becomes positively charged since it lost an electron. In other words, they both become ions, atoms with electrical charges. And since opposite charges attract, they bond together. This is called electrostatic attraction. Sodium chloride, which is just table salt, is held together by ionic bonds. That's a good point. On their own, sodium and chlorine atoms have totally different properties than salt. Sodium is a soft metal that burns the skin and explodes on contact with water. And chlorine is a poisonous green gas. But when these 2 elements react, they form an ionic bond, and we get an edible crystal. Yep, covalent bonds can change an atom's properties too. Hydrogen and oxygen are both invisible gases, and hydrogen is explosive. But when they react, they form water, a very stable liquid. If you break that covalent bond with a little electricity, you get hydrogen and oxygen gas again. No, wait! You know, every week it's the same thing. I teach you something cool, you shoot a laser beam out your finger, and I get in trouble. Well, not this time. I'm gonna pretend I didn't hear that.
Okay, back to this. Okay, so we know why they combine now, which is groovy. Now I want you to do a couple of short worksheets on counting atoms and figuring out the difference between elements, compounds, and mixtures. So it's a double-sided worksheet. When you're done with this, note-taking lecture, you can come up and grab that worksheet. I just want to quickly go over in a compound like water, you have 3 elements or 3 atoms, and you can see that by looking at the hydrogen, which is right here, has a 2 next to it, so you would count 2 hydrogens and then 1 oxygen is next to it. So on that worksheet, you're just counting the number of atoms in each compound. If you need help with that, just let me know. The other side is telling the difference between the mixtures, the compounds, and the elements. So like I said, let me know if you need any help, and good luck. This is the end of this presentation.